Okay, this is another video from A3. In A3, we're learning all of our derivative rules, and this video is going to focus on just the product rule. So just to give it away right off the bat, if we have a function, let's say p of x is equal to f of x times g of x. So you got two functions multiplied by each other. It turns out that the derivative is actually, you can take the derivative of the first times the second plus the derivative, plus the first function times the derivative of the second function. So that's what the product rule is. So you're taking the derivative of the first function and then multiplying it by the second function. And then you're just taking the first function and multiplying it by the derivative of the second function. So that is the actual product rule. And let's prove it. Okay, so you don't ever have to do this. I'm just going to prove it using first principles so that you can see that I didn't just make it up. Okay, so here's your proof. So the derivative p prime x equals the limit as h goes to 0 of p of x plus h minus p of x divided by h. So that's our first principles definition. Now, if we pretend that this is our actual function, f of x times g of x, then we can go ahead and write it into our first principles definition. Okay, so that's going to turn into, the first part, this right here, is going to turn into f of x plus h times g of x plus h minus, then this part is just straight p of x, so that's just going to be f of x times g of x. And the whole thing is divided by h. Okay, so we're going to just do something really weird, because that's what we do in proofs. Because we can't go anywhere from here, we're actually going to add something into the middle of our function. So we're going to take f of x plus h times g of x plus h, and we're going to add in a minus f of x plus h times g of x, and then you can't just like add in a random thing, so you can't just subtract a random thing, so we're also going to add that random thing so that it's actually like we didn't do anything at all. And then we're going to end off with our minus f of x g of x. So, I'm just going to highlight this. I stuck this into the middle of, what we had in the previous line. So we normally just had the f of x plus h g of x plus h minus f of x g of x. But I shoved in that highlighted part in the middle, which is weird, but you can do weird stuff in proofs. And the reason I did that was so that we could we're going to be able to factor it. Okay, so first we're going to separate it using our limits rules. We're going to separate it into two separate limits. So we're just going to break it right down the middle here and separate it into two limits. So we're going to do the limit of f of x plus h times g of x plus h minus f of x plus h g of x divided by h. So that's going to be our first one. And then our second one is going to be, so let me get plus, and let me write another limit as h goes to 0, and then we're going to do the second half, so f of x plus h times g of x minus f of x, oops, I wrote g. Okay, minus f of x times g of x, all divided by h. Okay, so we're just proving this here, and it's crazy. Okay, so now that we have them split up, we can actually, if you look at the top here, you'll actually notice that they both these terms have an f of x plus h. And so there's definitely a reason why we added and subtracted these two things into the middle. It's because we know what we're trying to prove. So there you go. Okay, so we're factoring out an f of x plus h. And what we have left is a g of x plus h minus g of x divided by h. And we're going to do the same thing for the other limit. We're going to factor out, this time, we're going to factor out a g of x. And what we have left is an f of x plus h minus f of x. The whole thing's divided by h. I hope you can see that we're kind of looking like we're getting some kind of first principles thing going on here and here. Okay, so next step. We're going to pull out our common factors. So I'm actually going to pull out this guy. I'm going to write the limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of this g of x stuff. So g of x plus h minus g of x divided by h plus, I'm going to do the same thing over here, limit as h goes to 0 of g of x times the limit as h goes to 0 of f of x plus h minus f of x over h. So using our limits rules from, back in A1, we can totally split them up into separate limits. And now we can sub in 0 for h. And we see that once we do that, like that goes away. So I'm just finding the limit as h goes to 0 of f of x, which is just going to be equal to f of x for this. Now this one right here is not just going to be equal to g of x, it's actually equal to the derivative of g of x, which we can write as g prime x, plus, then you'll notice this one right here, the limit as h goes to 0 of g of x is just going to be equal to g of x multiplied by this guy is actually the derivative of f of x, so f prime x. And if I just write that in the reverse order, like if I write this one first, f prime of x times g of x plus f of x times g prime of x, then I've just gotten the same thing I showed you up top. So this right here is our product rule. And I just proved it, and it is a little complicated and would be way better if I could do it in class, but I'll have to settle for a virtual video. Okay, so that is the product rule. And let me just show you one example of how you would use that using actual numbers. Okay, so let's say our p of x is equal to 3x minus 5 times x squared plus 1. So this is like our f of x, and this is like our g of x. Okay, so if we want to find the derivative of p of x, we just use our product rule, which says f prime x times g of x plus f of x times g prime of x. We just have to follow that formula. Okay, so we're finding the derivative of the first function. So what's the derivative of 3x minus 5? It is just 3. Okay, and then we just write g of x. Okay, cool. So g of x is x squared plus 1. Done. Then we put a plus sign. Okay, now we just write the first function, f of x, which is 3x minus 5. Okay, then we take the derivative of g of x. Okay, so the derivative of that would be 2x. Okay, we're done. And then you could just simplify this if you wanted to. I don't know if you do, but it would be 3x squared plus 3 plus 6x squared minus 10x, which would be equal to 9x squared plus 10x, oh, just kidding, minus 10x plus 3, I think. Cool. So that's product rule. So you just like follow this handy guide. Derivative of the first times the second, derivative of the second times the first. And that is the product rule.